So we're going to begin our last chapter, the Chapter 5 review. So Chapter 5, what we're working with on Chapter 5 is mostly number value, number operations, understanding numbers. You think we would have gone over this in Chapter 1, but here we are now. So our first question is to graph these on a number line. So I want you to make 3 number lines, and we're going to graph them. Take your time. There's 3 different, A, B, and C. Graph each one on their own number line. Okay, Romario, graph 1A for me.
Oh.
Romario is still graphing. Go ahead, Romario. Keep going.
Is he graphing?
Yeah, and that's pretty much it.
Excellent. So now you have to plot the points.
Wait. Oh, okay. Like circle it?
Yeah, you just put a dot where it is on the number line.
What the heck?
Just, yeah. Just touch it once. And then. Perfect. Who agrees with him? Thumbs up. Awesome. Everybody should. It's correct. Hannah's graphing our second number line.
Hi, Hannah. Hi. No, hide back. Be like that. Oh, this one here.
Oh, hold on. You're using the big one, but it's okay.
Oh.
There you go. Keep going with the thin one. Go ahead.
Wait.
Now I'll have you plot your points. Okay. There you go. So she's plotting her points now.
That didn't function.
Pause it so I'm giving you time. Perfect. So Hannah did this perfectly. We initially had a small mistake, but she looked back and fixed it, and now we have it graphed perfectly. Thank you so much, Hannah. Now I want to invite Fernando up to do number C. So Fernando's going to be graphing C. Excellent. So Fernando set up his number line, and now he's going to graph the points. Just tap. Yeah. Excellent. Do we agree with him?
Yeah.
Yes. Great job. So what do we notice about Romario and Hannah's number line? What do we notice about their number lines? Let's see, Rafi.
Fernando doesn't have a 0.
Yeah, so exactly. Hannah and Romario's both have a 0 in their number line. Fernando's doesn't. Does that mean Fernando's wrong? No. You can start a number line anywhere on the number line. The one rule is that the spacing between each number has to be the same. Had somebody done a spacing where they did 1, 0, -3. Doesn't work like that. Can't do it. Illegal. You will go to jail. No. Our next problem should be very easy. Solve the absolute value. Before we start, who can tell me a fact about absolute values? Miles?
If it's like negative, but it's inside the 2 lines, it'll still be the positive.
So if it's inside the 2 lines, our answer is always positive. Exactly what Miles said. If it's inside the 2 lines, our answer is always positive. So for absolute value of 25, what's the answer? Raise our hands.
25.
Gore. 25. It's not negative 25 because it's still it comes out positive. What about negative 14, Liam?
Negative 14. It would be 14.
14, perfect. Now, Gloria, what about negative 20 minus 17? We get 3 because we get negative 20 becomes 20 minus, it stays 17. We get 3. Here's a tricky one. Let's see. I want to see, Lucy, what is negative absolute value of negative 5? Negative 5. But what? I thought all absolute values were positive. What is this, Hannah?
That only happens if the sheet is on the inside.
Exactly. It only happens to what's on the inside. Whatever's on the outside doesn't matter. That gets applied later. Now, absolute value of 1 minus 2. First of all, what is 1 minus 2? What is 1 minus 2? Let's see, Romario. 1 minus 2 is not 1, but we are close, Malia. Negative 1. So this absolute value becomes the absolute value of negative 1. What's the answer? 1. And then lastly, and this one should have been easy, absolute value of 31 plus the absolute value of negative 31. What is that answer? Who can tell me? Let's see, Trey.
62.
Yes, 62. Exactly. Everybody should be able to get these. Whatever comes out of an absolute value is always positive, but it can be impacted by whatever comes beforehand. So for example, I just want to show us a trickier example that you might see later. What is the answer to this problem? I'm going to give you guys a chance to think about it, and then I want to hear your answer. So, Rafi, what's the answer? Not negative 5. That's another good guess. What's the answer, Michelle? 14. Lucy had it too. So, Michelle, how did you get 14 as your answer?
Because the absolute value of negative 7 is 7. And then it would be 2 and 7. But if there's no symbol, then you have to multiply.
Exactly. If there's no symbol, if something is just touching, just like we know with our parentheses, what we know with our distribution, if it's just touching, it's multiplication. So we get our answer to be 14. So what we're doing is we're trying to solve the inequalities. So go ahead, Liam, and you can solve them.
All right, spin. That, like that.
Okay, so let's see. Do we agree with the first one?
Yes.
Yes. So we agree with this one? We agree? Yeah, we should. Do we agree with the second one?
Yes.
Yes. Do we agree with this third one? No. Do we agree with the fourth one? Yes. So I'm going to have Daniel come up and, well, actually, it's really easy. The other one, when we flip it, it is to this side. Daniel, why is it to that side?
Because it turns positive and 19 is bigger than 13.
Exactly. In the absolute value, it turns positive, so 19 is bigger than 13. Exactly, guys. So we order from least to greatest. A couple of you ordered from greatest to least, which is just embarrassing. Okay, let's go through this. Which one is the least? Who can tell me which one is the least? Jaden.
Negative 79.
Perfect. Negative 79. Which one comes next, Miles?
Negative 55.
Negative 55. Which one comes next, Nathan?
Negative 10. I mean 10.
There is no 10. There is no 10.
So what is that?
But Nathan, yes, 18 comes next. Gloria, what comes next?
44.
44. What comes next? Let's see, Emerson. 101. And then what comes last, Trey?
43.
143. Exactly. Don't worry if I saw on your test that you had put 10. I adjusted because technically you were following what you believed to be was least to greatest. So that's okay. But pay attention. Next problem. Write each fraction as a decimal. So we're going to write each fraction as a decimal. How do we go from fraction to decimal again? Who can tell me? What do I do? Daniel? Long divide. And use bar notation if needed. What does bar notation mean? What does bar notation mean, Michelle?
It's when it's repeating the decimal and you put the little bar
Exactly, it's when it's a repeating decimal. For example, 33.3, that goes on forever. We say this because that's equal to 1/3. So we put the repeating decimal over that. So I want you guys to solve this problem first. Okay, let's start, Madison. I want you to solve this problem. There's 2 parts. Go ahead.
Okay. So we have to divide, right? Yeah. So we have to divide.
We have to divide, exactly.
Wait, which one goes where? I'm so confused.
So Madison's continuing. She's doing her long division. Go ahead, Madison.
You want me to speak?
You can speak, you cannot. Whatever makes you comfortable.
I won't. What? Okay. This is a 0. It looks like a potato.
So what are we noticing, Madison? It's repeating, right? So what kind of decimal is it? You can just put an R if you don't want to. We can do that. Excellent. So we get that as our answer. Now, there was a negative in front of it, so all it becomes is negative 0.2 with a bar notation over it. Excellent. Rafi, come on up here for B. So, Rafi, do our division.
Wait, how do I erase this? It's so big. Oh, wait, no. Erase it. Like that?
Yeah, so he's going like this. Perfect. He made it into an improper fraction, and now he's doing his division. Great job.
No. 5 does not fit into 4.
He's doing a great job so far.
0.
So, we did this. Now, there's only one problem here. Can anybody notice the one problem that he did? What's the one problem? Let's see. Hannah, what's the problem?
You're supposed to divide 4 by 5.
Yes, we're supposed to divide 4 by 5 because it becomes 5 divided into 4 groups. So it's 5 divided into 4 groups. But I'm going to show you how to solve this 2 different ways. So the first way, we have 5 divided into 4 groups. 4 goes into 5 one time. 4 minus, we get 1. We bring our decimal. How many times does 4 go into 10? Number of fingers? 2. That is 8. We get 2. We bring this down. Number of fingers. How many times does 4 go into 20? 5 times. That's 20. We end. We get our answer to be 1.25. Let's look at this trick method. We already know that there's going to be a 1 because it's already 1 and something. So it's going to be 1 point something. At this point, all we need to do is divide 1 into 4 parts. It becomes, we have the whole 0, then it's 10, then it's 2. And then we do the same thing, 2, 0, 5. So once again, it becomes 1.25. We already knew that with the 1. That'll help us with letter E. Is this repeating or terminating? Terminating because it does not continue. Okay, Gore, come up for number 3. Okay, Gore, begin. Perfect so far. What do we notice here? Exactly. Perfect. Is this repeating, Gore, or terminating?
Repeating.
It's repeating. We get 0.4 with our bar notation over. Next, I want Michelle to come on up. This one's a bit long. Michelle did this, and really quickly, actually. So what we notice is that it goes pretty long. But as I pointed out before, here's a 60 minus 56. There's a 60 minus 56. That means our problem is going to keep repeating. So we get as our answer this really long thing. 0.85714 with bar notation, and it is repeating. Okay, Nathan, come on up for this one. Nathan, begin this problem. So he made it into an improper fraction, and now he's going to do the division.
No, I messed up.
So he noticed he messed up. Go ahead, continue.
Oh, now I'm choking. Can I see my answer on that? Come. Can I see my answer on that?
So he got 2.4. Is that terminating or repeating, Nathan?
Terminating.
Terminating, exactly. Once again, the quick way we could have done it is know that it's going to start with a 2 because it's bigger than 100. And then we divide 2 into 5 groups. We get 0. We get 4. 2.4, and it is terminating. Excellent. For this problem, we're going to label each plot point as an ordered pair. Remember with our ordered pair, what comes first? What comes first, Hannah? X comes first and then Y. Alphabetical order. Exactly. Anita, where is point A located? So what do we get for A? So what do we get, Hannah?
You get
2, 3. We go forwards 2. We go up 3. Okay. Point B. Point B, Gloria.
Wait. -2 and -6.
-2, -6. We went over 2. We went down 6. Okay. Lastly, for point C, Carmen. -3, 4. Exactly. We went over 3 and then up 4. Great job. Now, the last part of this. What quadrants are they each in? What quadrant is A in? Who can tell me what quadrant A is in?
1.
Let's see, Nathan.
1.
A is in quadrant 1. What about B? What is B in, Elsie? 3. And what is quadrant C in, or what is C in? Let's see, Hannah. 2. Exactly, guys. Perfect work today. Thank you. I want everybody to write these down in their notebooks, and I want you to solve them. Like I pointed out, many people got it wrong because they didn't notice the negative signs. The negative signs impact something because, for instance, what's bigger, -1 or -2? Who can tell me which is bigger? Let's see, Joey. -1 is bigger. Normally, 2 is bigger, but because it's negative, it's the opposite. So I want you to write these down and try them out. So one of the issues that we're having with this problem, the problem is that people don't know how to match them. So here in a lot of them, we have both fractions and decimals. Fraction, decimal. So not for all of them, but for most of them. The easiest thing to do, by the way, is to turn your decimal into a fraction if you know it. If not, you do long division to turn your fraction into a decimal. So let's think of this first one. -8 and 2/5, right? Let's see. Here we've got -8.3. What is 0.3 as a fraction? Who can tell me what 0.3 as a fraction is? Chase? 3/10. Now, that's still hard to see because I've got 2/5 and 3/10. I need to make them over the same denominator. How can I get 2/5 to be on the same denominator as 3/10? What else can I do, Shiley? Divide? No, not divide. What can I do, Chase? Multiply times 2. 5 times 2 becomes 10. And then this becomes 4. Now, a lot of you guys were eager beavers and you think, oh, 4 is bigger than 3. Great. But they're negative. So, who can tell me which one's bigger? -8 and 4/10 or -8 and 3/10? Who can tell me, Emmett?
-8 and 3/10.
Excellent. That one is bigger. So as such, I want you to do the same for the rest of them. Keep going. So let's see. We're going to start from bottom to top. Chris, What's the answer for F? What'd you get? That they're equal. Exactly. We know that because negative 3.25, 0.25 is 25 over 100, which simplifies to 1/4. Again, if we divided 1 into 4 groups, we would get 0.25. So we find out that they're equal. Excellent. Izzy, what did you get for letter E?
I got that the 3.25 as much as like that one.
The first one or the second one? Which one?
Second.
So you think this one's bigger? So let's see who agrees with her. Thumbs up, thumbs down. Thumbs up if you agree. Thumbs down if you don't agree. So we're seeing a mix. Let's see what it is. When we have this continued, when we have the bar notation, it means it keeps going. 5, 5, 5, 5, 5. Is that going to be, because it's a negative, more or less than 3.25, Shiley? It is going to be less because it's negative. Once again, she would have been correct had it been positive, which is why these are so tricky. Okay, let's see. Sean, for D, what did you get?
Well, I'm still doing it.
We're going to do it together. The easiest way to do this one is to make the 2/7 into a decimal. We simply divide 2 into 7 groups. 0, 2, 8. Hey, but look already. We didn't even really have to do much. We found out that our first number started with a 2, and this one starts with a 3. But they're negative. So which one is bigger? Who can tell me, Emmett?
Negative 9 to 7.
Excellent. We already got that 2. That's smaller than that 3, but because they're negative, it's reversed. Exactly. Okay, let's see. Jaden, for C, what did you get?
5 1/5 is bigger.
5 1/5 is bigger. Thumbs up if you agree, thumbs down if you don't agree. We see some agree with Jaden, we see some don't. Shiley, Sean, why do you not agree with Jaden, Sean? Caesar.
Because making 5 1/5 because making 5 1/5 into a decimal would be 5 would be 5.2.
Excellent. It matches. We would get 5.2. Again, if we made the negative 5.2 into a fraction, we get negative 5 2/10, which simplifies to negative 5 1/5. So these two are equal. Excellent. Dominic, let's do this last one. So what did you get, Dominic? So we're going to do this together. You better be taking these notes, everybody. So we already have 1 as a decimal, and that's going to be pretty hard to make as a fraction, especially with that bar notation. So let's just make the other into a decimal. We've got negative 4.7 bar notation, and then we've got negative 4 4/5. We're going to divide. 4 divided by 5, 0, 8. So we get negative 4.7 forever and negative 4.8. Which number is the bigger number, Dominic? Perfect. The negative 4.7 continuing on forever. Exactly, because it's closer to our 0 on our number line. Great job with this, everybody. To make it so you don't have to draw the graph, we're just going to graph it together. Okay, D, negative 3, 2. Okay? Negative 3, 2. Am I going to go up or down or left and right first? Who can tell me up or down, left and right? Shiley? Excellent. She said because the middle one, the one that's across the horizontal, is the x-axis. We're going to go left, right first. Negative 3, which direction do we go? Left or right, Emily? Left. So we go to this negative 3. Then 2. Now we go to the other axis. Up or down, Emmett? Up. We go to that 2. We meet, and our point of D is right there. Excellent. As such, we do the same for the others. E's negative 5, negative 5. They meet right there. And F is for negative 1. It meets right there. So when we do this, we always go x, Y. Pay attention to that, okay? Now, here's what it's going to ask you. What quadrants are these all in? So first of all, I want you to write down these points. We're going to look at point A, B, C, D, E, and F. So look at this on your paper and write down the quadrants first. So A, B, and C, and D, E, and F. A, B, C, write down what the quadrants are for A, for B, for C, and then for D, for E, for F. Shiley, what quadrant is A in? Quadrant number 1, exactly. What about B, Chase? Quadrant 3. What about C, Izzy? Quadrant 4? Not quadrant 4, that's a good guess. What is it, Izzy? 2. Excellent. Let's go back and look at D, E, and F. What quadrant is D in, Emmett? 2. What quadrant is E in, Shiley? 3. And what quadrant is F in, Brendan?
4.
4. Exactly. As we know, the way that our quadrants work is it actually goes counterclockwise. We start here and we go around. 1, 2, 3, 4. In quadrant 1, both values are positive. In quadrant 2, X is negative, Y is positive. Quadrant 3, both negative. In quadrant 4, we get positive, negative. So this might be something you would want to write down because it's kind of good knowledge to have. So if negative 3, 2 is reflected about the x-axis, the new ordered pair is what? So what happens when you reflect across the axis? What is a rule you have to follow, Izzy?
The rule that you have to follow is when you reflect across like the x-axis, the x number will, I think, stay the same, and then the other one will flip.
Exactly, she's correct. When you flip across whatever axis, that value stays the same. So since we're flipping across the x-axis, Shiley, which one stays the same? Negative 3. And what happens to that other one? What happens, Emmett?
It becomes a negative.
Yeah, changes. Becomes a negative 2. It just changes. As such, the last one that we're going to look at is if 5, negative 4 is rotated about the y-axis. The new ordered pair is what? I want to see. Justin, can you tell me the ordered pair?
Y negative, 5 negative.
Perfect. We get negative 5, negative 4. Because in this case, the y value stayed the same and our x became the opposite. It became the opposite, which is negative and or positive. So for example, if we had this point, if we had negative 3, 2, and we reflected about the y, what would our new point be? Who can tell me? Shiley?
It would be
3, 2. Exactly. It doesn't always have to be both negative, doesn't always have to be both positive. Whatever it is, whichever axis you are flipping it about, it stays the same and the other one becomes the opposite. Excellent job, you guys. Perfect.